The psychology of testing. Software development, including software testing, involves human beings. Therefore, human psychology has important effects on software testing. Human psychology and testing. Identifying defects during a static test such as a requirement review or user story refinement session, or identifying failures during dynamic test execution, may be perceived as criticism of the product and of its author. An element of human psychology called confirmation bias can make it difficult to accept information that disagrees with currently held beliefs. For example, since developers expect their code to be correct, they have a confirmation bias that makes it difficult to accept that the code is incorrect. In addition to confirmation bias, other cognitive biases may make it difficult for people to understand or accept information produced by testing. Further, it is a common human trait to blame the bearer of bad news, and information produced by testing often contains bad news. As a result of these psychological factors, some people may perceive testing as a destructive activity, even though it contributes greatly to project progress and product quality. To try to reduce these perceptions, information about defects and failures should be communicated in a constructive way. This way, tensions between the testers and the analysts, product owners, designers, and developers can be reduced. This applies during both static and dynamic testing. Testers and test managers need to have good interpersonal skills to be able to communicate effectively about defects, failures, test results, test progress, and risks, and to build positive relationships with colleagues. Ways to communicate well include the following examples. Start with collaboration rather than battles. Remind everyone of the common goal of better quality systems. Emphasize the benefits of testing. For example, for the authors, defect information can help them improve their work products and their skills. For the organization, defects found and fixed during testing will save time and money and reduce overall risk to product quality. Communicate test results and other findings in a neutral, fact-focused way without criticizing the person who created the defective item. Write objective and factual defect reports and review findings. Try to understand how the other person feels and the reasons they may react negatively to the information. Confirm that the other person has understood what has been said and vice versa. Typical test objectives were discussed earlier. Clearly defining the right set of test objectives has important psychological implications. Most people tend to align their plans and behaviors with the objectives set by the team, management, and other stakeholders. It is also important that testers adhere to these objectives with minimal personal bias. Testers and developers' mindsets. Developers and testers often think differently. The primary objective of development is to design and build a product. As discussed earlier, the objectives of testing include verifying and validating the product, finding defects prior to release, and so forth. These are different sets of objectives which require different mindsets. Bringing these mindsets together helps to achieve a higher level of product quality. A mindset reflects an individual's assumptions and preferred methods for decision-making and problem-solving. A tester's mindset should include curiosity, professional pessimism, a critical eye, attention to detail, and a motivation for good and positive communications and relationships. A tester's mindset tends to grow and mature as the tester gains experience. A developer's mindset may include some of the elements of a tester's mindset, but successful developers are often more interested in designing and building solutions than in contemplating what might be wrong with those solutions. In addition, confirmation bias makes it difficult to become aware of errors committed by themselves. With the right mindset, developers are able to test their own code. Different software development lifecycle models often have different ways of organizing the testers and test activities. Having some of the test activities done by independent testers increases defect detection effectiveness, which is particularly important for large, complex, or safety-critical systems. Independent testers bring a perspective which is different than that of the work product authors, example, business analysts, product owners, designers, and developers, since they have different cognitive biases from the authors.